example 2. So find the max and min. Find the max and min values of f, let me do it over here, of f of xy equals 3x plus 4y on the circle x squared plus y squared equals 1. Okay, so one thing you should know about these max-min problems, and we'll get more of a taste of this when we do some more examples in the next lesson, the problems are not written out the same way. Oftentimes you're given information that doesn't look like a Lagrange multiplier problem, but you have to extract information. In other words, sometimes you have to extract what f is, extract what g is. It's not always going to say find the maximum and minimum values of f subject to g. You know, it's not going to be as explicit like this. But again, we'll see more examples of that. Okay, so find the max and min values of this function on the circle x squared plus y squared. So all this means is that this function 3x plus 4y is defined for the entire plane, but we want to constrain it, and we want to find the maximum and min values on this circle. So somewhere, some point on this circle is going to maximize this function, and some point on this circle is going to minimize this function. So f subject to the constraint g. Okay. So let's see here. What shall we do first? Well, okay. We're going to do what we always do. We're going to take the gradient of f, and we're going to set it equal to lambda times the gradient of g. Okay, and we're also going to, so we're going to have this set of equations, and we're also going to have g, in this case xy, is equal to 0. That's our last equation. We have to satisfy these two equations, or this set of equations. Okay, so the gradient of f, this one is going to be, so the partial derivative with respect to x is 3. The partial derivative with respect to y is 4. So we have 3, 4 equals lambda times the gradient of g, that's going to be 2x. Let me make this a little bit better. Is going to be 2x, and this is going to be 2y. So we have lambda, or I'll write 2 lambda x and 2 lambda y. So there you go. So this corresponds to that. This corresponds to that. So we have the equation 3 equals 2 times lambda x, and we have 4 is equal to 2 times lambda y. Yes, that's exactly right. And of course we have the g of xy equals 0, so we're going to get x squared plus y squared minus 1 equals 0. So this is our set of 3 equations in 3 unknowns, x, y, and lambda. We have 3 equations and 3 unknowns. Theoretically, this is solvable. Now we just have to find x, y, and lambda. Ultimately x and y, but lambda along the way. Okay, so let's see what we've got here. Okay, well, I think the best way to approach this is, since we have this equation and we have this, I'm just going to go ahead and solve each of these equations, one for x and one for y. So in this particular case, x is going to equal, I'm going to divide by 2 lambda, so it's going to be 3 over 2 lambda. And y, when I divide by 2 lambda, is going to be 4 over 2 lambda, which is equal to 2 over lambda. So now I have x, oops, and these crazy lines showing up all over again. All right. Lambda, this is 4. So I have x, and I have y, and now I'm going to take these values of x and y, and I'm just actually going to put them into this equation to see what I get for lambda. So let's go ahead and do that. Let's do that on the next page. So I have the function x squared plus y squared minus 1 is equal to 0. And we said that x is equal to 3 over 2 lambda. So this is going to be 3 over 2 lambda squared plus y is equal to 2 over lambda squared minus 1 equals 0. So let's go ahead and work all of this out. 9 over 4 lambda squared plus 4 over lambda squared minus 1 equals 0. We're not going to leave anything out here. I'm going to go ahead and multiply through by 4 lambda squared, I think. No, just 4. Yeah, 4 lambda squared. Okay, so when I multiply by 4 lambda squared, I'm going to get 9 over here. I'm going to get 16 over here minus 4 lambda squared equals 0, just to get rid of the denominator. That's all I did. Now 9 plus 16 is 25. That equals 4 lambda squared. So lambda squared equals 25 over 4. Therefore, lambda equals plus or minus 5 over 2. Okay, so we found lambda. Now it should be not a problem. So now that we found lambda, well, x is equal to 3 over 2 lambda. So when I put that in there, that's going to end up equaling, well, let's do it all. Let's not miss anything here. 3 over 2 times plus or minus 5 halves. So it's going to end up equaling plus or minus 3/5. Now y is equal to 2 over lambda, which is equal to 2 over plus or minus 5 halves, which equals plus or minus 4/5. And I hope I've done my arithmetic correctly. Okay, now let's stop and think about this. We have plus and minus 3/5 for x, and we have plus and minus 4/5 for y. Now, you're probably thinking to yourself, just like for the previous problem, that we have 4 points. 3/5, 4/5, 3/5, negative 4/5, negative 3/5, 4/5, negative 3/5, negative 4/5. That's actually not the case, and this is where you have to sort of look at other things. There's other analyses going on here. X equals 3 over 2 lambda, y equals 2 over lambda. X and y have the same sign, so they're either both positive or they're both negative. So we don't have 4 points to pick, we only have 2 points to pick. One in the first quadrant, one in the third quadrant. That's what's going on here. I mean, you can go ahead and use the other. That's not a problem. You're going to get the answer, but just something else to, be aware of. So that's it. So basically, our points that we're going to pick are, let's see, so 3/5 and 4/5, that's one possibility. And minus 3/5 and minus 4/5, that's the other possibility. Okay, when I take, so let's just call this P1 and let's call this P2. So when I take f of P1, in other words, I put it back into the function, 3 times 3x plus 4y, 3 times 3/5 plus, well, you know what? Let me actually work it all out. It's probably a good idea if I work it all out. Yeah, okay, I'll do it on the next page. So we'll do f of 3/5, 4/5. That's going to equal 3 times 3/5 plus 4 times 4/5 equals 25/5. That's going to equal 5. And f of minus 3/5 minus 4/5 equals 3 times minus 3/5 plus 4 times minus 4/5 equals minus 25/5 equals minus 5. So here at the point 3/5, 4/5, it achieves a maximum. The maximum value is 5. And at negative 3/5, negative 4/5, the function f achieves a minimum of negative 5. So we have found the maximum and minimum values of 3x plus 4y subject to the constraint that x and y lie on the unit circle, x squared plus y squared equals 1. That's what's going on here. Okay, so again, in the next lesson, we're going to continue on with more examples of Lagrange multipliers because we want to be very, very, very familiar with this. And then after that, we'll pull back a little bit and we'll take a look at what's exactly going on. We want to make sure that you actually understand why this is the case and why this works. Again, nothing theoretical. We just want to make it plausible for you, that this isn't just some technique that drops out of the sky. Thank you for joining us here at Educator.com. We'll see you next time. Bye-bye.